It's a real pleasure to introduce Nikhil Garg, who is an assistant professor of operations research and information engineering at Cornell Tech as part of the Jacobs Institute. He uses algorithms, data science, and economics approaches to study democracy, markets, and societal systems at large. Nikhil has received the NSF Career, Inforum's George Danzig Dissertation Award, and honorable mention for the ACM SIGCOMM Dissertation Award and paper awards including from CSCW, YAML, and CHIL. He received his PhD from Stanford University and has spent considerable time collaborating with government agencies and nonprofits. His work has also been supported by the NSF, NASA, Sloan Foundation, and other organizations. Welcome, Nikhil.
Cool. Thanks for that introduction and for having me here. Sort of really excited to talk about sort of this work that we've been doing for the past few years. And Sasha already told me that sort of this audience likes to ask questions. So, let's make this as interactive as possible. Sort of that's the more fun way to do it. Yeah, so, I was just saying, because I've been workshopping this talk and title and so on. So, I think I'm going to talk about, things that are very sort of core to a lot of things that people here at CITP think about. And so I'm really excited to talk about it today. And so the driving question for a lot of my work over the past few years has been sort of this one that's on the board, which is like, why are products that we could use for the public in public interest context? So like here on the left is like a flow chart that you might need to navigate if like you're thinking about sort of what Medicare option sort of to do. And this is from a screenshot from a really nice book on administrative burdens, right? So like whenever we think about interacting with the government, sort of we think about flow charts like the left. And whenever we think about sort of, watching a movie or hunting for an apartment, it's like sort of interactive, great, sort of capable web systems like the right? And so the a driving question is like why? Like why is this true? And one answer, which there's been a lot of great books written about it. Y'all should read them if you haven't already. Is like clearly true, which is there's like an institutional sort of question, right? It's building things is hard and expensive, and maybe the public interest is not necessarily geared to like building these hard, expensive things. And that's like clearly true. And not necessarily for bad, right? As we're learning over the last years, like you might not want government to build fast and break things, right? So like you want an appropriate level of risk aversion. But I think sort of another answer, which is maybe of interest to academics, is that sort of there are real scientific, methodological open questions that are different when building for the public interest than sort of building sort of for like Netflix or apartment hunting and so on, right? Which is like, even if we magically solved all these institutional burdens, it's like unclear what we should do in many of these contexts, even if like institutionally you could do it, right? And so a lot of sort of this work sort of associates like missing data and serving sort of how do you like equitably serve distributed spatially diverse populations and so on. And so today, I'm going to talk about sort of this work we've been doing with New York City Public Schools and sort of the methodological things that you see here are all sorts of like behavioral heterogeneity, right? So how do you deal with the fact that people behave differently, and then sort of there are various capacity constraints and externalities in equilibrium. Before I dive into sort of the meat of the presentation on sort of what we've been doing with New York City Public Schools, I wanted to sort of step back and give another view on this question of, I think there being real scientific bottlenecks to working in the public interest, which is sort of maybe the closest thing to a manifesto that I've written sort of in my life. I think this is the only single author thing I've also written in my life, which is sort of, I think one attempt to look at is like, where has potentially various scientific communities either gone wrong or sort of, I think, understudied various questions that are core to our field. And that is, which is, so like I come from, I'm natively come from the economics and computer science community, sort of market design and so on. And sort of, I think our core sort of ethos, if you ask anyone in our field, is that people know things that institutions do not, right? Is sort of people have preferences and knowledge that central entities sort of should incorporate in decision making, right? So we have democracy is good. Participatory budgeting, regular democracy. We have crowdsourcing, so you can report a pothole or you can report some like fire hydrant exploding or so on, and then the government sort of maybe takes care of it. And then what I'm going to talk about today is we have school matching, right? Is parents and students have preferences over where they want to go to school, and maybe we should take that into account when making government decisions, right? So this is the core ethos, I think, of a big community. Empirically, however, wherever we've had the most success, including school matching, which I'm going to talk about today, basically what you fundamentally observe basically everywhere is participation is like heterogeneous, right? It's diverse. So in participatory budgeting in New York City, voting rates are like, if you do napkin, like they don't release the voting rates, but if you do the napkin math, it's roughly about 2% of the eligible population. Part of that's because they make it eligible to everyone. Any 11-year-old and older who is a resident of New York City can vote, right? So the denominator is big, but still 2% sort of participation rates. And it's spatially heterogeneous. Sort of a lot of my early work as faculty was sort of thinking about heterogeneous reporting in crowdsourcing systems, right? So I live near Columbia in the Upper West Side. If a pothole happens, it's going to get reported very quickly, right? Maybe in other neighborhoods in New York City, that's not quite true, right? So how does that sort of skew government allocation? And then today, what I'm going to talk about is we have this great choice system in schools in New York City, but then like how do people actually use it, and how does that skew government allocation? Right, and so I think often stepping back to sort of AI systems and so on, is we always sort of build systems with either theorems that say that they can work, or the best of intentions of how people like us can use them, but sort of empirical measurement of how are people using these systems when deployed in the wild is, I think, sort of the first order question that should be driving a lot of our work. I'm going to sort of jump through this and sort of the next question one can ask, and I think that's core to a lot of the great work happening at CITP, is what do you do about it, right? Is how do you sort of meet people where they are, both in practice and in research, and sort of with that this is, I think, what the North Star of a lot of my sort of econ CS work has been, which is, let's build all these great things that we can build. Let's use preferences and information from those who choose to participate, but then build our systems with the fail-safe, right? Is sort of when people maybe don't participate or don't use our systems as we might want, is how does we as government still provide a sufficient quality of service? And so sort of with that, I'm going to sort of now start diving into what we actually do in this work, and sort of with just sort of my version of this answer, sort of maybe the title of the talk, has been sort of, we need sort of end-to-end methods of, again, the type of things that people here at CITP do, from like applied math modeling to a lot of computational social science, to then inform deployments and then sort of post-deployment evaluations of our systems. Today, I'm going to talk about sort of this sort of project that I'm really excited to start talking about. Sort of, it's been like, I think, two and a half years in the making. Sort of, we first reached out about the data in spring of 2023. And so sort of, and it's now sort of just now getting public. And so I'm really excited about all of this work, which is about the New York City High School Match. And I'll sort of define that in a few minutes. And the first question is really descriptive, right, is how do applicants behave when they're applying to schools, right? Are they making good decisions? Are we happy with the decisions that they're making? And then sort of maybe the more prescriptive question is how do we build algorithmic support tools to help people make better decisions here? This is joint work with a whole bunch of excellent collaborators. Erica Chang, Kenny Peng, and Emily Rue were the PhD students here. Kenny and Emily were undergrads here at Princeton and sort of, I think, worked with various CITP folks. And so sort of really thankful, please keep sending great undergrads to Cornell. And then John Kleinberg and Eva Tardash are, maybe many of you don't need an introduction, but sort of our senior faculty at Cornell. Before I get started on the work, though, I do sort of want, this talk is in memory of Emily, who sort of tragically passed away last fall, and sort of, she was really wonderful to work with, and, I think all sort of the co-authors and friends are really sort of, don't really know how to honor her, but this is my attempt at doing so. But, I'm excited to talk about the work that sort of she played a great role in. Hard to transition from that, so I'm not really gonna try. Okay, so what is the context? So the context is the New York City High School Match. How does the New York City High School Match work? Every year, about 70,000 eighth graders match to up to now over 900 high school programs. And how it works is historically, students can rank up to 12 programs. As of last year, they could rank all 900 if they wanted to. So they took that limitation away. And then they're matched through the deferred acceptance algorithm, which sort of, if you're not familiar with it, the details aren't really important for the talk. And sort of a basic fact of this system is that there are a lot of disparities in outcomes, right? So, and you can look at, and that's true for any definition of disadvantage, and essentially any metric that you look at, right? So for example, the median Black or Hispanic student matches to a program that has roughly double the fraction of students who do not graduate high school, about 43% higher fraction who do not enroll in college, and then New York City has a whole bunch of school performance metrics that combines a whole bunch of metrics, and so about half a standard deviation lower school performance. And then they also try to sort of control for sort of incoming class, so they try to do some causal effect type thing, and so about 0.3 standard deviations sort of lower impact. It's sort of an attempt to be causal, right? So the deferred acceptance system was sort of built so that everyone could have an opportunity to go to school anywhere and to equalize access to opportunity, but sort of by any statistic you look at, there are substantial gaps remaining.
Sorry, just to clarify, are there any preferences on the schools?
Yes, and I'll get into that. Yeah, great. Okay, so then there are three sort of potential reasons this could be true. The first one is, geography, that sort of where do kids live related to, compared to where high-performing programs are, and maybe that affects both sort of admissions policies, but then also that affects preference. I don't want to travel 2 hours for school. Maybe some of you do travel 2 hours to come to Princeton, but maybe the average high schooler does not. Right, so geography clearly could explain some of it. Like Arvind was asking, is schools have preferences, right? So New York City pretty extensively uses, even some of you might have heard about the 9 specialized high schools like Bronx Science and so on. I'm actually setting those aside. They operate a parallel admission system. Even setting those aside, many of these 900 high programs use things like grades. Historically, they use test scores. So there's a whole bunch of sort of admissions policies contributing, sort of, that schools have, right? And these two could be driving a lot of these match disparities. You can think of these as the supply side. Another thing that you might believe is that application behavior is driving at least some of these disparities, right? So quote unquote controlling for geographic access and admissions policies. Disadvantaged students are not applying to high performing schools that they can get into. And again, either you can tell like a true preferences story that they truly prefer to go to the schools that they're applying to, or you could tell a complex process informational story, which is that sort of they would apply to these schools if sort of someone told them about it or encouraged them to, or so on. Other thoughts or questions right now? Okay. And for those of you who don't have kids in New York City, I just want to emphasize that this is an overwhelming process, right? So these are all screenshots from like the website New York City uses, sort of to show people about schools in New York City. And it's actually, if you've used StreetEasy, which I screenshotted earlier in the slides, it actually really is just the schools for StreetEasy. Like it's actually a good website, but it's an overwhelming website, right? So you have like these 900 programs. For each program, you see what language courses, AP classes, what sports they offer. You can like dig into and look at like impact and performance, all of the metrics that you might care about the school, survey responses, category scores, right? It's like a whole bunch of information is available on these websites about schools. But at the same time, like how do you navigate all this information? You could imagine that sort of some people are more sort of have more resources and sort of context to be able to navigate all these resources. So this is this article came out the day the application closed this last year, sort of the title, Pity the 8th grade Parents in New York City's 8th grade. Like if you ask any parent in New York City, this is like a full-time job of like applying their kid to high school. Right, and another way you can see this is if you Google New York City high schools and you don't have an ad blocker, you're going to see a bunch of ads for consultant services to help your kid, to help you navigate the process, if you can, afford the thousands of dollars, right? So this is a hard process. I'm going to sort of skip this, but sort of just to say, is a whole bunch of people have been studying disparities in this process in various ways, and like not just in New York City, but in college admissions and outside of New York City. First, I'm going to talk about the descriptive work that Kenny and Emily led. And sort of the goal of this project was to exactly try to disentangle the role of behavior from admissions policies and geography, right? So one story that you can tell is like, yes, the process is complex, but like that's actually not what's driving all the disparities, really, right? So like if you read any of the news about New York City high schools, what you're probably going to see is most of the focus is on admissions policies. Like should schools be using test scores or grades or so on in order to rank students, right? That's where a lot of the dominant discourse is, right? So first you might just want to understand is there a role on the student behavior side? And if not, then maybe you should intervene on the policy side, or maybe intervene on the school side, depending on what the answer is, right? In particular, the question that you actually care about to figure out where to intervene is what we're going to call undermatching, which is where could a student have matched to if they had just applied differently, and how does that compare to where they actually matched to, right? So, and then we also say no further geographically, right? And we're going to say someone is undermatching if they match to a school that's quote unquote lower quality according to the metrics that we look at than the one they could have matched to had they applied. And how do you actually answer this question? It turns out with enough grad student sweat and the data that's now available, you can reverse engineer sort of all the school policies and the entire deferred acceptance process, right? So you can build actually a program level simulator and then calculate counterfactual admissions through the deferred acceptance process for roughly about 80% of seats. The remaining 20% of seats use things like auditions and essays and like things that are not observable for someone who doesn't apply. But for the remaining 80%, you can basically get this at like 95 to 100% accuracy, right? So we did that. We sort of, we looked at sort of, you have to like just like work through all of the like schools have various diversity criteria and grade tiers and lottery numbers and so on, but you can do it, right? So you can construct these counterfactuals. And then once you construct these counterfactuals, you can just directly measure undermatching, right? You can just say, here's where they could have gone, here's where they went, look at the difference. And then the next thing we do is we ask is, okay, it's not just enough to say that many students are undermatching. If you're going to launch an intervention, you want to understand is sort of what different behaviors should I try to convince someone to do, right? Is all of the undermatching happening because sort of disadvantaged students aren't applying to competitive enough programs first? Or is the undermatching happening because maybe they're not listing safety schools at the end? Right, and you might imagine that the answer is different for different groups. Right, so it does turn out that sort of most of the undermatching for disadvantaged students are happening because I don't list, or I do list a fairly non-competitive local high school first, and then it doesn't matter what the rest of the list is. And so really, for disadvantaged students, you want to intervene at the first spot on the list. And maybe the one more thing I'll say there is, over the past few years, New York City has been really focused on the end of the list. So the end of the list is where not matching happens, right? As I apply to 12 schools, I get rejected from all of them, and then I get administratively matched. And New York City has been really focused on making that less common. That is actually sort of disproportionately advantaged students. It's sort of only historically applying to a bunch of competitive programs. Okay, and so what I'm going to sort of make the normative assumption for this talk is that quality metrics matter, right? It's things like program selectivity, competitiveness, graduation rate, college enrollment. I'm going to assume these metrics matter. If you're sort of a true revealed preference economist, you might say they don't matter, that sort of student preferences are the only thing that matter, and students sort of tell you what they want, but I'm not going to do that. Okay, and so what do we find in the descriptive work? The first is that sort of application behavior is actually the leading contributor to match disparities at the individual level. And so what I mean by that is the average difference for an individual between where they applied and where they could have matched is much larger than like average differences between groups of like where they could have matched, right? So application behavior is driving most of these disparities. And sort of what this map is showing is basically just average undermatching by New York City zip code. And if any of you are familiar with New York City, this is basically, like the phrase all maps of inequality are the same. This is essentially sort of showing that. And so like one way to see that is, so this part of New York City is called Riverdale. It's actually a relatively rich area of New York City, but it's a very remote area of New York City. Right next to it is the Bronx, which is a relatively disadvantaged area of New York City. Students in these neighborhoods have relatively similar access to schools in the sense of like geographically where they are and roughly actually where they could be admitted if they were to apply. But Riverdale students are basically applying to as high quality schools as they can get into, and that's not true for students in the Bronx. The second fact that you observe is all the disparities are coming from the most competitive applicants. So you can sort applicants by some measure of competitiveness. So for example, what is the quality of the best school they could have gotten into, or various metrics like that. And so here on this plot, left is most competitive, right is least competitive. And the y-axis is undermatching. And again, what you observe is sort of both raw undermatching levels are highest for the most competitive students, and then the differences between Black and Hispanic students and white and Asian students are also largest amongst the most competitive applicants, right? So most of the effect is concentrated among students who have like high test scores, grades, and lottery numbers. And then the third thing you find is that, so this is plot is for Hispanic students, but you see the same plot for Black students, is essentially all the effect is in the first spot on the list. So the way to read this plot is the x-axis is the list position, like where should I optimally intervene in their list, and the y-axis is what should I tell them to do. And basically this is saying is the number one recommendation you make to all Black and Hispanic students is apply to a much more competitive program first, right? This is like something like 80% of Black and Hispanic students is that's the optimal recommendation according to the model. For white and Asian students, that's still the modal recommendation, like apply to a much more competitive program first. But now you see much more spread that for many of them, actually the optimal recommendation to improve their outcomes is to apply to safety schools.
So does that mean that the more competitive program is already among those 12, it's just not ranked in the first place?
So this is not showing that, but that's also true. So what's also happening for a lot of students is they do have a competitive program somewhere on their list, but it's just after a program that accepts everyone. And so sort of you get essentially the same results if you limit to programs that's already in their list.
So if it is lower down on their list, why does it make sense to interpret that as undermatching as opposed to reveal preference?
Yeah, so I mean, I think sort of that's where like your prior comes in and sort of which explanation you might sort of buy. Sort of one answer to that is why I don't think it's just revealed preference is what you'll see for a lot of disadvantaged students is they still fill out like, 7 or 8 schools. Like actually the average list length is the same between sort of basically across groups, but their first program accepts everyone and has accepted everyone for many years, and they know that, right? So like if you truly understood everything about the process and sort of knew that your first program was the choice and accepted everyone, then you wouldn't fill out the rest of your list, right? So for disadvantaged students, sort of what I'm calling effective list size, which is the length of the list until the first school that accepts everyone, is shorter, even though the average list length is the same length. So, there's no real answer to your question, but that's one indication why I don't think it's just revealed preference.
You mentioned earlier that there was a cap of 12 school students could apply to, and then that cap was relaxed to 0900. I was wondering if you could talk a bit about what would happen if you didn't match anywhere because of the cap, and then also, have you noticed a change in behavior once that list was expanded to potentially as many schools as you want?
Great question. So if you don't get matched algorithmically, there's like a human administrative match process, like some staff member in New York City Public Schools will just assign you to a school based on neighborhood and whatever is available. The second question is, I haven't looked at that directly, but I suspect not much has changed because I think the cap is kind of a red herring and that the cap wasn't actually affecting outcomes historically. Like historically, most students get their top 1 to 3 choices and the average is like fill out 8. It's like, I don't actually think the cap was the binding constraint for the vast majority of students. It's actually sort of this other question of like, how quickly are you just ranking 100% acceptance off grade school?
Can you talk a little bit, is it like, I only have a kid in the DOE system for elementary school, but sort of we have the same gaming thing with like waitlisting, because if you get your first choice, then you don't get waitlisted for the other schools, right? But like if you put a competitive school at the top, you get into your second choice, you do get waitlisted for the first school and you might get in, right? So I think that explains why that number 1 spot is so important if it's the same process for high schools. If I put a competitive school number 1, I don't get in, but I get
but exactly.
I'd be waitlisted, so I have a chance to get in.
Yeah, so that's even more reason why you would want to sort of actually apply according to your 2 preferences.
Yeah. And is there anything in the application outline in the UX design that like, because for elementary schools, it gives you immediately, when you put in your address, it gives you its own school, and it sort of feels like a preference that the system gives you. Is that also in the high school where it's like,
it's less prominent, but yeah, so you have zone schools and you have sort of continuation schools. But yeah, it's less prominent partially because they potentially want to encourage people to sort of travel. Okay, so these are, I think, the three summaries of the descriptive work. Is application behavior is a leading contributor to disparities. Disparities happen amongst the most competitive students, and sort of the place to intervene is pretty simple. It's at the top of the list. So what did we do is we ran exactly the intervention you might want to run if those were your descriptive findings. So this is work led by Erica Chang, who's a PhD student at Cornell, and then Kenny, John, and Ava as well. Okay, right, so what did we do? We informed applicants from what I'm gonna call a target middle school about high-performing nearby high schools where they have a high chance of admissions, right? So the high chance of admissions sort of targets competitive students to those high schools. And then we picked target middle school as one that consistently sends very few students to high-performing high schools, even though those students could have been admitted to high schools, right? So we did targeting at the middle school level, we used no demographic information. And then high-performing is defined sort of in conversation with New York City Public Schools. It ultimately was some combination of graduation rate, college and career readiness scores, and safety. Okay, so this is the intervention as we sent emails to these students about these high schools. And the key to this is, so this is really great work by Viola Corradini and Clemence Ido, is as of last year, so as of the 2024-5 cycle, New York City now shows you its estimate of whether you'll get into a school. So they'll now give you buckets, high, medium, low, that's personalized according to your lottery number and grades and application, of does New York City think you'll get into this school? And these are course buckets where if you look at the website, they say that high means 99% chance, low means 1% chance or less, and medium is everything else. It's actually fairly distributed amongst the three. Sort of, it's not that everything is a medium. And I'm happy to talk about this design offline. But this is something they've already done. But now what's the problem? The problem is the entire goal of our intervention is to change application behavior. But these acceptance rate calculations were trained using historical data that didn't assume our intervention, right? So our intervention, if it has any chance of success, like if our intervention is successful, we're taking the acceptance rate calculations out of distribution. Right, so if you look at data from the first year that they offered these acceptance rates, they're actually pretty well calibrated. So what I'm showing you is acceptance rates at each program amongst applicants who had a high offer likelihood for that program. And it's, the website says 99, and it's essentially above 95 for every program. There's like some small tail of small programs where maybe it's noise, but it's essentially calibrated. What I'm showing you here are simulations of what if we ran an intervention that was pretty successful, that was actually very successful, right? Is what if we ran an intervention and then people actually changed their behavior because of our intervention? And what you see is now a whole bunch of programs have acceptance rates of like 50 to 70%, even among students who were told their acceptance probability was like 99%. And worse is this is happening geographically, right? It's sort of if we run a naive intervention and we just the exact naive intervention I told you on the first slide, is now acceptance rates for students in the Bronx actually goes down even maybe as low as 10 or 20%, because they're all being nudged to one of the very few sort of what's defined as high-performing high schools in the Bronx. And so sort of this, it was essentially a deal breaker for the New York City partners, right? Is sort of, you're launching an intervention that's telling people to apply to schools and telling them, hey, you have a 99% chance of getting in. And then in effect, it's sort of anywhere between 20 and 70%, right? And this is bad for all sorts of reasons. You don't want to lie to people, sort of, it's ineffective. And it's gonna affect sort of future interventions take up. And so this was sort of the driving constraint of what we did, which is how do you preserve offer likelihoods while sort of nudging students to high-performing high schools. Right, so here's the sort of the research question, which is how do you nudge applicants such that if some fraction follows them, then they were actually a good set of recommendations. Right, so maybe slightly more formally, suppose I have a set of applicants that and schools that I'm gonna call desirable matches. And so this is, someone attends a target middle school, the high school is high performing, and the student would get into that high school. And it's not that far away, right? And our objective is to maximize the number of these desirable matches. The only thing we can actually do is send recommendations. We can't actually force anyone to apply anywhere. And now we have this sort of non-negotiable constraint is that you can't lie to people, right? Sort of acceptance rates still better be high if you told someone they have a high chance of getting in. Right, and the way we operationalize that in this paper is you want to design the recommendations so that if some percentage X of applicants actually followed them, then some percentage Y of these high likelihood students are still admitted. Right, so, and what I want to point out is sort of why is a policy question. It's not something that sort of, maybe I as the engineer can have an opinion that you shouldn't lie to people, but like why is ultimately a question for like the domain partners, right? Are they comfortable with 80%? Are they comfortable with 95, 98? What is that question? And then X is sort of, you just have to guess how effective your intervention will be. Or you're super conservative. I'm running out of time, and so I'm gonna sort of skip over the method. For those of you who've sort of worked in optimization type problems, I'll quickly summarize for you, but sort of intuitively what we do is we say, for each program, we have a nudge cap. We're not gonna send more than 10 recommendations to this program, or 50 recommendations, or 100 recommendations. So we have that sort of nudge cap. And then given these nudge caps, we're gonna optimally sort of allocate the recommendations so that sort of as many students as possible at least get one nudge. And then given that, at least as many get 2 nudges, and so on, right? And how we calculate those nudge caps and how we do the integer program is something I'm happy to talk about offline, but essentially you do it like back and forth. First you calculate the nudge caps, then you allocate recommendations, then you check your constraint, and then you adjust, and then you do that in a loop. Okay, and then, so what does the effect of this recommendation do? Is it essentially, well, first it caps recommendations to each program, and then it redistributes them toward sort of the students who most need that program. So for example, what you see here is, so this is Bronx Latin High School, which is the only high school that sort of met the high-performing high school definition that our partners set, that's in the Bronx, right? And so what that means is because this is sort of the most north high school in the Bronx, that's deemed high performing, for students who live in the very north end of the Bronx, this was the only high performing high school that was within 45 minutes, right? And so if you just sent recommendations to everyone, naively, you're nudging sort of students all over the Bronx, part of Riverdale, part of North Manhattan, in Harlem, to that high school. But essentially what our integer program is doing is saying, no, all of these students down here have access to a whole bunch of other high-performing high schools if they travel south that are pretty close to them. So I'm going to nudge these students down here, and then I'm going to nudge these students down here. That's essentially what our integer program is doing under the hood. Okay, so then you do all this math, you do all this work, and then sort of, the amount of work she did last year was incredible, of like everything you have to do to actually run an RCT in government. Right, so like work with a whole bunch of teams in New York City Public Schools to like, what does high performing mean? We have to run focus groups on how families are going to use nudges. All materials had to be translated in 12 languages. Ultimately, the chancellor of New York City Public Schools had to approve the intervention, as well as sort of each superintendent for schools that we nudge people to, and so on. Right, so sweeping a bunch of work under the hood, but then sort of Erica did all of that while also doing the data science. And then this is ultimately the email that we ended up sending, which is just dear guardian. So all emails in the match are sent to parents. So dear guardian, name, your child has been selected to receive a personalized list of programs to high-performing high schools, all are within 45 minutes. Here's how we define high-performing, and then here's the list of programs. And what I want to note here is two things. One is this is the weakest possible intervention you can imagine, right? The number of emails these folks are getting from the high school system, the application system, is insane. And this is yet another email they're getting from that system, right? So an incredibly weak email intervention. And then two is this email gives no information that parents technically don't already have, right? So the portal already tells them they have high likelihood to get into that program. And sort of all of these scores are available to them, right? So from an information perspective, we're actually giving them no new information. We're just making it salient.
Did you consider an intervention that gave some information about strategies? Like in the descriptive work, you saw that like intervening at the first few in the ranking, like this doesn't really indicate to me that I should rank them up top.
Yeah, so the part of the screenshot I didn't include sort of was like, remember in deferred acceptance, or in the algorithm we use, you should rank them in your true order of priority. New York City very much does not want to say you should rank something first or second, right? They very much don't want to say this school is better than that school, and so you should rank it first or second. What sort of they're comfortable saying is, here are high-performing schools, and then right after they're comfortable saying, rank according to your true preference. Now, if you like juxtapose those two facts, sort of they want to let people make their own decisions.
Can you talk about how you all agreed on an email, because it feels less invasive versus having it actually on the application, that when I put in the closest school, it would say, hey, great choice, but
I
you
mean,
should consider this.
the lame answer is software engineering constraints. You know, you can only build so much and integrate into a sort of a government website in a given year. I sort of integrating in the portal is definitely where I want to go. You couldn't do everything in 1 year. But yeah, I think sort of there's many reasons to believe this is the weakest possible thing you can do. Okay. And then we also did an extremely conservative design this year, right? So the X and Y that I told you is we assume that 40% of applicants follow nudges. If any of you have run an RCT, especially an email RCT, you would know this is the most successful RCT in the history of humankind, right? So we assumed we were extremely conservative. And then sort of, we also said the constraint would be 95% of high likelihood students still gotten in. Ultimately, we sort of had about 500 treatment applicants and 800 control applicants. At the moment, we only have application behavior changes. The match outcomes, I think, get released next week, the week after. So we will get match outcomes soon. Right now, we just have application behavior changes. And what we find is that I was expecting a no effect this year because, like, again, weakest possible email you could imagine. What we instead find is, so in the control group, about 10% of applicants applied to the program we would have nudged them to if they were in the treatment group. Defining that is a little bit, defining that carefully is a little bit hard. Happy to talk about it offline. But 10% applied to the hypothetical nudge program. In the treatment group, about 16% applied. So a small absolute effect, but a huge relative effect. And this is you can do all the stats you want and, clustered standard errors and strata fixed effects and so on, and statistically significant. Right, so this was way larger than I was expecting in terms of a weak email. Okay, so I'm gonna end here and maybe return to the original questions, which is first is like, why are public interest products less capable than those for private ends? Maybe I don't need to say that for this crowd, but I do think it's true is that both we have serious institutional constraints that yes, we should all make progress on. But then two is I think we do have scientific gaps that that maybe researchers are not fully addressing by just focusing on maybe commercial products, right? And so in this work, what we saw is yes, we very appropriately were risk averse in all of these ways and had constraints of we can't integrate in the official website this year, but then we had to develop real new methods to deal with this recommendation congestion issue, right? As to meet the needs of the system. And what my vision and a lot of the work that my group has been doing is the style of the work that I just showed, which is full stack and developing these methods, but then deploying them with practitioners and then evaluating them. And then I'll end here, which is I think just this reminder that in the context of this work is we can prove all the theorems we want about the mechanism being strategy proof and there being revealed preference, but what we should care about is how the systems are actually being used and what are the implications of the systems that we're putting out in the world.
It seems to me that chatbots, particularly for a website like this, would be extremely valuable. I don't know how much they're used even when they're offered.
Yeah, great question. So I'll say address the second part first. Is I think that's the lesson of most of these interventions, is that roughly anything is effective if it's used or if it's seen, right? So the problem isn't the third turn of the chatbot or right, the effectiveness of the chatbot comes in, it's does it do anything beyond a static email? But I think most of the ineffectiveness of interventions is the email isn't even opened that tells them about the chatbot, right? And then if so if you have the information in the email versus the email has a link to the chatbot, then they use it, I think that would, it doesn't matter how effective the chatbot is I think you already lost most of the people.
But the application is on the web, so you could put a chatbot right there.
So I think if you put it there, I think that as I think once you can integrate in the official portal, I think doing interactive things becomes more feasible. And so that's one of the things we want to do next year, which is we probably won't get to chatbot level next year, but at least ask questions of what are you interested in and so on. Yeah, I think one constraint about chatbots is everything New York City sends out at the public school levels has to be translated to every language that the parent, parents say is their at-home language.
That's not really a constraint for chatbots. I'm using Claude and it easily handles 100 languages.
I think it's not maybe a technical constraint, but it might be a bureaucratic constraint of validating that it'll do a good job. I think that's probably where the bigger constraint comes in.
Do you have an insight? You showed this wall of ads. So what do consultants actually do? Is it parasitic or do they actually provide value? And what would it take for you to replicate kind of whatever they're doing for free?
Yeah, that's a good question. So if you asked me this like 3 years ago, I think the answer is that there was actually a lot that they could be doing. Because like 3 or 4 years ago, and this is just apparent in the data, is like schools were using all sorts of weird things to rank students. Like they were like, did you attend the open house for this school, right? Like many schools, like they say they had an essay, but the essays were binary graded. Like, did you submit a text file that that claims to have an essay inside? Right? So like there was all this hidden knowledge of like what are the schools actually ranking on. Over the years, New York City, and this is like all unannounced, like you have to like talk to the people and look at the data and so on. New York City has increasingly centralized how the rankings are done away from school officials into like the central office, like sort of the school will still say, I want to rank people according to this metric, but then the central office will actually run the algorithm, right? So like, I think if you ask me now, I actually don't know like what value these consultants could be offering under that system. 3 years ago, there was a lot of hidden knowledge.
2 questions if you have time. One quick one, you mentioned that the issue of is the email even opened, and I'm just curious if you have analytics on the emails that you sent out. Then the other one, a bit open-ended, I'm curious if you've thought about, especially in terms of the equilibrium effects, what widespread improved matching will do for the schools themselves in terms of applicants self-sorting by quality or...
Yeah, great question. So we very purposely chose not to track email opens, like that felt a little too invasive. We did track email clicks. So we did track clicks on links to, so like the email I showed you, it linked to the school, like sort of the school's page on the application portal, and we tracked those links. Amongst people who clicked those links, so I showed you 2 numbers, 10 and 16, like 16 in the treatment group. Amongst people who clicked on the link, that was like 30%, but there's huge confounding, right? There's huge compiler confounding there, so I don't really want to read into it. And then the second thing to say about that is the sort of the treatment effect went beyond the people who clicked on a link. So it seems like a lot of people opened the email and then either Googled the school or like just applied without clicking on the link. So like I think that it's just like not a great measure. The second thing about sort of equilibrium effects and so on. So one lame answer I'm going to give you is by only recommending students that have high likelihood of getting into a school, all sort of in effect, all we're doing is aligning matches more in line with what New York City claims it wants to, like more in line with what New York City is claiming it wants the students at those schools to be, right? So, maybe higher performing disadvantaged students at those schools or so on, right? So like, to the extent that there are equilibrium effects, it's the ones that New York City is claiming it wants. That's an incomplete answer. The other answer, which is I think a real problem in New York City, and one that they're really worried about, is New York City has like small high schools. And so one challenge in New York City is a lot of schools are too small to offer many AP classes. Like Calc BC is actually not offered in most New York City high schools because they're too small to have enough students to offer a Calc BC class. And so to some extent, because of the smallness, you do want sort of bunching of students who would take Calc BC at the same schools. And so to the extent that our nudges by focusing on the competitive applicants is sort of helping with that I think that's what I would hope the equilibrium effect would be.
Sorry. I know Mamdani announced that like he's getting rid of like say the gifted program in like New York City public schools, like,
Elementary school level.
or elementary school level.
Yeah.
How are you like handling those kinds of exogenous shocks or like any other ones that like anything at the policy level?
Yeah, I think those are great questions. So, yeah, one is like, my personal opinion is that gifted programs at the elementary school level are very different than ones at the high school level. And, you know, I do think at the high school level, like it is like what I was just saying is like, it is an issue that many schools can't offer CalPC, right? So to the extent that you want to sort of offer CalPC, you need to do some level of sort of bunching of students at the high school level. But I think to your broader question of policy shocks, I think sort of that's why we started with the descriptive work of like, and I think that's some of the role of like computational social scientists is like try to inform what policy should there be, right? So like one of the lessons I take from the descriptive work is like, yes, we should be thinking about admissions policies and, you know, maybe change them in various ways. I actually don't think that that's going to be enough to do anything, right? I like sort of, if you're using that as your lever, like I actually don't think that's going to be that effective of a lever by itself, right? So I think like instead of treating it as exogenous shocks, I would say is like, as an academic, you should try to create the shocks that you want.
Can you talk a little bit about sort of the internal talk at the DOE and amongst your research team about sort of the fairness of the nudges? Because you are only giving this to like a certain select pool, right? Like in the DOE wants everyone to have the same chance. And the problem is they created this like complicated system that is only for the most dedicated people who spent a lot of time figuring this out actually manageable. And so it feels like maybe everyone should deserve a nudge.
Yeah, great question. So one is like, so you can, I think, view that at two levels. One is like, why are we only nudging students with high likelihood of getting in, right? Is, you know, medium, 50 doesn't mean 0, right? Maybe you should be nudging students with medium likelihood. So I think that's like a real normative choice, right? Is like, I'm limiting to high likelihood students. I think how we justify that is, again, going back to one of the previous answers is sort of New York City policy has already declared it prefers these students over that students at this high school, right? That's what's inducing these likelihoods. Like New York City is saying, if these two students apply, I would like this one to get in and not this one, right? That's a choice that people have made. And so to the extent that our intervention is sort of preventing other things like information access and ability to navigate complexity, sort of is removing those things and just aligning to the choices New York City has already made, I'm pretty comfortable with that. I think the second part of your question is like broadly like the ethics of an RCT, like, we, even among students eligible, we had a control group, we had a treatment group. Is that sort of ethical? And I think, again, I think there's two levels to that. One is, at the very least, by our congestion constraint, we didn't make it worse for the control group, right? It's not like sort of we recommended someone in the treatment group and then they displaced someone who was in the control group, right? The design of the RCT was to prevent that from happening. The other one is just like broadly is like, you ran an RCT, you gave someone a benefit and not another person a benefit. I think, I think sort of that's a much bigger question that sort of everyone who runs RCT should think about.
Okay, I have one last question about the control group that you put out, because you said you controlled the control group is if the people have the same high school that you would recommend. But is that actually, is it the most likely case, or is it also like, would you, if they put a very high ranked school in a different neighborhood, maybe they're also pushing up?
Yeah.
And would you catch those cases?
Yeah, so how we define the control group, so we randomize at the middle school level, And then for some of the middle schools, we randomized within the middle school. And so, yeah, the randomization was like a standard. Our CT randomization is we didn't look at anything about the students when assigning to treatment and control. Where that complicates things is then saying is, what school would the student have been nudged to if they were in the treatment group? And for that, essentially what we did was we just pretended the control group was the treatment group. We ran our method, and that sort of resulted in the recommendations we would have sent them if that was the control group, and then we compared to that.
I mean, I don't know anything about like how New York City schools actually work. But like, what's to stop someone just from listing all the schools within, like, say, 45 minutes of them in descending order of whatever quality metric?
Yeah, I mean, I think.
And wouldn't you eliminate any, I guess, under matching?
Yeah, I mean, I think like if everyone behaved like sort of true economist believers, believed everyone behaved, then like none of this would be an issue. Yeah.
Thank you very much, Nikhil.
Thank you.